Welcome back. In this video, we'll learn about K-Medoids clustering algorithm. So first, we'll learn what is K-Medoids. K-Medoids is a partition-based clustering algorithm which is similar to K-means but more robust to noise and outliers. Instead of using K-means as centroid, that is mean as the centroid for the cluster points which we usually use in K-means. In K-Medoids, we'll be using the actual data point itself. This actual data point which we use as the center point is called as the medoid. Okay, here the most popular algorithm which we usually use is partitioning around medoids, PAM algorithm. Next, we'll see the key concepts for K-Medoids algorithm. In this K-Medoids algorithm, we need medoid. So, how we will be selecting the medoid? Medoid is the most centrally located object in a cluster. So, it means that this is the one with the smallest average dissimilarity to all other objects in that particular cluster. Then we need a distance measure. What kind of distance measure we will be using? We can use any other distance measure similar to the K-means algorithm like Euclidean distance, Manhattan distance. Okay. Now we learn about partitioning around medoids. The first step is the initialization step. So in this step, we'll select K objects randomly from the data set as the initial medoids. The next step is the assignment step. So here we will be assigning each data point to the nearest medoid based on the chosen distance measure. The next step is the update step, or otherwise we say it as an optimization step. So here for each cluster, try to replace the medoid with a non-medoid object and calculate the total cost, where this total cost is sum of distances of all points to their assigned medoid. So this is how the total cost is calculated. Total cost is equal to sum of I is equal to 1 to k, where k is the number of the features, and then xj which belongs to ci. If it belongs for all clusters, we will be doing this. That is, we find the distance from the data point xj to its center point. So we need to find for all data points, and so it is said to be the total cost. We need to repeat this until there is no change in the medoids or the maximum number of iterations are reached. So what is the output for this algorithm? We'll get the final medoids which represent the center of the clusters and each data point which is assigned to its nearest medoid. This will be the output. So you'll get the clusters, its center points, and with its data points. Now we'll look into an example. So here I have given a data set where we have two features x and y, and we have data points. These are the data points. First step, we need to select how many number of clusters we will be using and what are the center points. So here we are using two clusters. C1 is first cluster, C2 is the second cluster. Unlike K-means, in K-Medoids, what we will be choosing? We will be choosing a data point as the cluster center. That is said to be medoid. So in this case, 3, 4 is chosen as one cluster center, and 7, 4 as chosen as another cluster center. We'll be saying it as medoids. Now we need to find, using a distance measure, we need to find what is the distance between a particular data point to the cluster center. Okay, we have two clusters, so for the two clusters we will be finding out, and whichever cluster is having the least value, that cluster, this data point belongs to that particular cluster. So we'll try to calculate it. Here in this case, we'll be using the Manhattan distance. Manhattan distance is x1 minus x2 plus y1 minus y2. So here, consider the first data point, C6. We need to calculate it for cluster 1 as well as for cluster 2. So cluster 1 is, the center for cluster 1 is 3, 4. So what we will do, 2, 6, we need to find the Manhattan distance between 2, 6 and 3, 4. So the distance is calculated as 2 minus 3 plus 6 minus 4. We'll find the absolute difference between these two values and we'll get it as 3. So we found it as 3. Similarly, we can find for the next also. 3, 4 is the data point and 3, 4 is the cluster center. So it itself is the data point, and so we get the value as 0. Similarly, we calculate this value. We get the value as 7. Now we need to compare 3 and 7. 3 is the minimum distance. It means that for this data point to the cluster 1 center is having the minimum distance and the value is 3, whereas from this data point to the second cluster the value is 7, which is a higher distance. So this particular data point belongs to cluster 1. Similarly, we need to calculate for all other data points also. So when we calculate the value for all other data points, we get this way. So the first 4 data points belong to cluster 1 and the remaining data points belongs to cluster 2. Okay, now the third step is to find the total cost. So how to find the total cost? So we need to, this is cluster 1 and this is cluster 2. Cluster 1 data points, these are all cluster 1 data points and these are all cluster 2 data points. Now we are written it here. So for cluster 1, 3, 4 is the medioid, and for cluster 2, 7, 4 is the medioid. Now we need to calculate the total cost. This is the formula to calculate the total cost. In simple maths, how to do the calculation. So we need to find the cost between 2, 6 to its cluster center. Similarly, we need to find the cost from 3, 4 to 3, 8. Then we need to find the cost between 3, 4 to 4, 8. Similarly, we need to find the cost between 6, 2 to 7, 4, 6, 4 to 7, 4, 7, 3 to 8, 5, 7, 3 to 7, 4 to 8, 5 and 7, 4 to 7, 6. So these costs we need to find out. So that's what I have written it here. We'll be elaborating. We can apply the Manhattan distance. So from 2, 6 to the cluster center 3, 4. So what is the cost? The cost is, we have already calculated, it is 3. Similarly, 3, 3 to itself. So it will be always 0. Then 3, 8 to 3, 4, because 3, 4 is the cluster center. So it is calculated as 4. And similarly 4, 7 to 3, 4, which is the cluster center, we get this value 4. The pure Manhattan distance we get as 4. This is for first cluster. For second cluster, okay, this is for first cluster and this is for second cluster. We have calculated all the values. We need to calculate the total cost. So this is for first cluster, right? 8 plus 3, which is 11. And here it is 5 plus 4, it is 9. So the total cost is 20. Now after finding this total cost, now we move to the fourth step. What is the fourth step? We need to randomly select one non-medioid point and recalculate the cost. We need to select any other non-medioid point. Medioid points are 3, 4 and 7, 4. These are the medioid points. We need to select one point which is non-medioid point, anyone from any of these clusters, and then we need to recalculate the cost. So here I am selecting the non-medioid point as 7, 3. So this point I am selecting. Okay. Now for this for this, as the cluster center, we need to recalculate the cost. So to do this, I am swapping C2 with O. So instead of C2, I am replacing C2 with O. Okay, C1 is 3, 4, which is the cluster center or the medioid, and here instead of cluster 2, I am mentioning it as O, and this is said to be the center is said to be 7, 3. So for this 7, 3, we need to recalculate the values, the distance measure, and then we need to find the total cost. So C1, the cluster 1 is as such, remain as such 3, 4. So all the values we will have it as such, and then the new cluster center we have is 7, 3. So all these values we need to find, and then based on the values we need to compare whichever is having the least distance. We will be selecting that as the particular cluster. Okay, here I have solved a simple example. I am using the Manhattan distance. So 2, 6 is the data point, and I need to do for the cluster 2. Sorry, this is O. Okay, for O, 7, 3. Okay, so we calculate the Manhattan distance, 2 minus 7 plus 6 minus 3. Whenever we take the difference, it should be the absolute difference, and we get the value of 8. So here the value is 8. Okay, here the value is 8. And now when we check it, here we have it as 3, and this is 8. Okay, so here it is 3 and here it is 8. So this data point, particular data point 2, 6 belongs to cluster C1. Similarly, we have calculated other values also. Based on that, we have segregated whether the data point belongs to cluster 1 or the data points belong to cluster O. Now, after finding this, we need to recalculate the total cost. So this is cluster 1 and this is cluster 2. So for cluster 1, this is the cluster center or medoid value, and for cluster 2, 7, 3 is the new medoid value, and for this we need to calculate the total cost. Total cost we have already found, the same method we need to use. So I have calculated the total cost here. So totally the total cost is 22. Previously we got the total cost as 20. Keep that in mind. Now we move to fifth step. So in fifth step, what we do is, we have done what we have done in the fourth step. Actually, we have swapped C2 with O. Okay, now we need to find the S value. S value, how to find? The current total cost minus previous total cost. Okay, so what is the current total cost? It is 22 minus 20, which is equal to 2. Okay, which is greater than 0. It means that swapping is not a good idea. Okay, just greater than 0. Okay, if it is greater than 0, swapping is not at all a good idea. The previous value was less 20, so that we can go for the previous clustering method itself. So the final output what we get are the medoid values. What are the medoid values? C1 is equal to 3, 4 and C2 is equal to 7, 3, because the previously just now we got right, one is 7, 3. 7, 3 issues leads to this problem. Okay, that's why we are selecting the second medoid as 7, 4. So the clusters, what are the clusters? C1 is the first 4 data points in the first cluster and the remaining data points in the second cluster. We got the output as the medoids as well as the clusters. This is all about K-Medoids clustering algorithm. Thank you.